Hello and welcome to Micrographics webinar. Today's topic is Fusion 360 live demo. As always, my name is Irshad Hanif and I'll be conducting this webinar. I'm an application engineer with Micrographics and we are going to get started immediately. All right. Fusion 360. So many of you would have been interested in using Fusion 360 as a 3D modeling software, and you're probably curious as to what it can do, what it can't do, how is it different from Inventor, and that sort of thing. Well, this is exactly why we decided to do this webinar. And we want to outline a small subset of features. Obviously, I mean, it's very broad and we cannot talk about every single aspect of Fusion 360, but hopefully you can get a better idea of what the software is, what it's capable of, and whether it will be right for you as a manufacturing company, a designer, or maybe just a hobbyist who's trying to make simple parts. Okay, so our agenda for today. Firstly, we're going to discuss a little bit about me, who I am, what I do. Also, just telling you what Micrographics is, where we are, and what we do. Then we're going to discuss the purpose of this webinar and just outline why we decided to make this webinar. Then we're going to just jump right into it and discuss a few aspects of Fusion 360, namely modeling, part and assembly creation, drawing and annotation, rendering, and manufacturing. Manufacturing being the CNC CAM workspace. Okay. And of course, at the end, we're going to have a live demo followed directly by a Q&A session. So if you have any questions or anything you're confused about during the presentation, you're welcome to ask at the end. You're also welcome to type in your questions as the webinar goes along, and I will be happy to answer them. But if it's something fairly complicated, it's best to just wait till the end. All right, about me. My name's Irshad Hanif. I'm an application engineer with Micrographics. I've got about 8 years of experience in mechanical engineering, and my primary areas of focus software-wise would be AutoCAD Inventor and, of course, Fusion 360. Now, I do also focus on CAM, CNC, FEA, design and modeling, as well as PDM, which is product data management. So if any of you guys have heard of stuff like Autodesk Vault, that is a data management software, and I'm also quite experienced with that since the past few years. Okay, I'm also an Autodesk certified professional, so that means I've taken the Autodesk exams and I've been registered with them as a certified professional. Okay, so why did we decide to make this webinar? Well, we wanted to demonstrate a subset of Fusion 360's capabilities. So we wanted to show the following, and I decided to break it down into 4 main ideas. Those 4 being Fusion 360 as a 3D parametric modeling software. So we know what parametric modeling means. It simply means that the design process is based on features and constraints rather than direct modeling. Okay, so the opposite of parametric modeling is direct modeling, and that is something like AutoCAD or one of the other generic brands. Okay, where direct modeling would involve simply drawing a line in space or on a 2D space or 3D space, and simply having that value fixed and not referenced to anything else. Whereas 3D parametric modeling would involve making shapes that are related to one another via features and constraints. So if you change one, it will change something else. This helps drive automation of repetitive changes a lot better than it would be on a direct modeling software. Okay, I see we have one more participant in the meeting. Welcome. Okay, so the next idea is that we want to show Fusion 360 as a design and production software. Sorry, as a design and production software. So that's basically meaning not only will you be able to model up simple things, but also create fairly complex assemblies, so multiple parts that fit in together, and you can control the design process and manage the data accordingly. Right? The next idea we wanted to see or demonstrate Fusion as a product documentation software. So here I'm talking about actually getting your designs out onto maybe a 2D piece of paper that you can show dimensions, annotations, markups, and you can hand on to the next process in your workflow, maybe hand it over to manufacturing, machining, that sort of thing. So product documentation, very important. And lastly, we wanted to show Fusion 360 as a CAM manufacturing software. This is super important because, as you know, in this modern age, CNC is quite common to make 3D machined parts. And a lot of the time you'd have to buy a special or a third party CNC or G code generating software. You know, I won't mention any names, and that can become quite costly. It's nice to know that Fusion has this built in, so you can go direct from modeling your part and getting out a G code within the same software without having to leave anything. All right. Now, Fusion can also do stuff like generative design and FEA analysis. So you look at stress analysis, thermal analysis, and a few other basic analysis. It's available in Fusion 360. However, that is beyond the scope of this webinar. So we're just going to concentrate on the first 4 topics here. Okay, but before we go any further, you may have heard something about Fusion 360 and the cloud. So let's discuss that. Fusion 360 is a cloud-based software. So what does that mean? It means that all of your work will be saved online in a Fusion project. So it's sort of like working with many of you will be familiar with OneDrive or Dropbox or something like that. Okay, it's the same concept. You will save it somewhere and it gets linked or synced rather to the cloud. And any changes you make, you can save it to that same place. It will update itself. And when you want to access it, be it on this particular machine or another machine, because it's on the cloud, you or your colleagues will be able to access that changed file. Okay, you can still export a local copy, but notice I've put local copy, the words local copy here. I've put them in bold because it's going to be a copy. You're going to export what you have there, local copy. You're not going to remove it from your cloud and put it locally and then be able to work with it. If you want to do that, you probably have to import it back to the cloud, make changes, and export again. Okay, so it works with a cloud-based system. Right? So does that mean I need internet access just to work in Fusion 360? The short answer is just no. You do have a little switch here, and it looks like this. If you look on the right, the small image here, there's a little switch to tell Fusion that you're working offline, and it will still allow you to do everything that you need to, right? Except, of course, importing new models, because it does use the cloud to convert models. So for example, if you had a design that was in STEP or maybe from SolidWorks, and you wanted to put it in to your Fusion 360, okay, you would still need to be online because it uses the cloud to convert that sort of thing. Okay, so what is a project? A project is a root folder, I put folder in inverted commas, that contains files and collaborators in a team. So it may contain, like for example, your company name and maybe all the projects that you guys are busy working with. And you'll see there are 2 tabs there, data and people, right? So you can include all the data in a particular project as well as the people that you want to collaborate with, and they can all see the same files. It helps you separate different jobs or maybe different pieces of work or different customers and clients that you want to interact with, right? Lastly, how do I collaborate? Well, you can simply add people to the projects or folders in your team. So like I said, the people tab up here, you can simply add people into your team. And you'll see there's a little diagram or a little image here of what it looks like in the people tab. I have multiple people. I've just added myself twice of course, with my work and private email. Right, let's discuss Fusion 360 workspaces. So the main idea with Fusion 360 is that it separates all your workflows into what's called workspaces. And those workspaces are design, generative design, render, animation, simulation, manufacture, and drawing. Right? The central idea being that when you're working in one workspace, you're only going to be shown tools that are relevant to that particular workflow. So for example, if you're into design, you're going to probably create solids, bodies, components, etc., and not going to worry about much else. Right? Once you're done with your design and you want to take this, for example, directly to your CNC machine, you can simply hop over to the manufacturer workspace and create a setup, put in your tool parts, and out comes your G code simply by switching workspaces. So that's the idea behind dividing everything up and not bombarding you with all tools all the time. Next, we're going to discuss the design workspace. So, like I said, from the previous slide, we have different workspaces. I'm just going to focus on one for now. Right. And in this design workspace, we can develop 3D parametric models. We can model parts and assemblies in the same workspace. So if you're coming from something like Inventor or SolidWorks, you'll probably be used to IPT and IAM or solid part and solid assembly. Well, in Fusion 360, they've done away with that. Everything's done in the same space, right? You can create surface bodies, you can create forms, as well as sheet metal parts. And you can see that they're separated, you can see that they're separated by tabs up here, solid, surface, sheet metal. So what format does Fusion 360 use? Well, its native format is .f3d. Okay, it's basically stands for Autodesk Fusion 360 archive file. It does not, like I said, even though it's an Autodesk 3D program, it does not use IPT and IAM, although you can import and convert these. Right? Why can you import and convert these? Well, because Fusion 360 does make use of Autodesk AnyCAD technology. That means it can accept files from any software, STEP, SolidWorks, Inventor, Creo, CATIA. There's quite an extensive list. If you're curious about what it can support, you can just Google Autodesk AnyCAD and it will tell you the full list of supported formats. Okay. Note that not all formats would convert directly. Remember, some will be meshes and it will try to convert and retain as much information as it can from the parent software. But of course, not everything will be saved if it's coming from a competitor software, such as SolidWorks. So, part creation. How do we create a part? Well, in Fusion 360, the default is set to part create. So in your design workspace, you'll see part and the part icon is shown. You can your part can consist of single or multiple bodies. So just straight out of the box, it does include the workflow of multi-solid modeling. Again, if you're familiar with Inventor or SolidWorks, that you might be familiar with what that means. You can create multiple bodies in a single part and do what you need with it. Both parts and assemblies save as .f3d, which we just learned about. Okay. Assembly creation. Well, you can insert models into your design or create new components in your design. So when you create your first body, it'll remain a part. The moment you insert another part into it, your logo or your little icon here changes and it becomes now an assembly. Okay, so as stated here in the second line. So when you insert something in, this will make your design an assembly, right? And you'll see the 3 blocks instead of the single block like here. Okay, assemblies. Okay, so this is an important point. Assemblies can have internal components or external components. Okay, so I've highlighted them in green and blue here, and I've put a little square around an example of each. So for example, an internal component, it means that it only exists inside that assembly. So lead, for example, here in this part, only exists inside my first part assembly. You won't really find it externally where you can use lead in another design. Whereas my second part will fall under the blue external. So external exists as a separate file in the project. So in your project pane, you'll be able to find my second part as a separate item, and you'll see its own space in the project window, which means you can use it in other designs quite easily. It's also, you'll note that it has a little chain icon, meaning that it is linked to an external part. So why did they put that there? They basically put that chain icon to remind us that it's linked. So if we change it somewhere else, maybe in the design or maybe in another design, it's going to change here. Why? Because it's linked, hence the chain symbol. Okay. Lastly, assemblies can also include sub-assemblies. So as with, I think, all other 3D parametric programs that work this way, if you have an assembly, you can also have an assembly inside of it, which will be called a sub-assembly. Okay, let's move on. Now we're taking us to the drawing workspace. And in the drawing workspace, we'll be able to document our design and see what we have. Okay, so it allows you to create 2D drawings and 2D engineering style drawings. So that means annotations and part notes and markups and that sort of thing. Right? You'll be able to do simple dimensions, annotations, markups, and symbols. Right? And I've listed a few here. So linear and radius, holes, bend lines, weld symbols, breaks and details, and zoom into certain areas. You'll be also able to insert a parts list for your assemblies. So for example, if you look at the picture on the right, I have a small parts list. It's got 3 basic parts in there. And you'll also be able to insert balloons and leaders. So little arrows with notes or little arrow with a balloon indicating what part which is. So for example, you'll notice that the parts list is numbered and it matches up to the balloon arrow pointing. That process is automatic, so you don't need to go and change it manually. If you say that's number 2, your parts list will update automatically, putting 2 with the right name and the right part. Lastly, we have the rendering workspace. Okay, and this allows for the creation of realistic renders. So you might have your design complete and made up, and you would like to put it out on a brochure or send it to a client. Well, this is where you would render your design. Okay, it renders using lighting and material controls. So it isn't advanced as something like 3ds Max, which is used for the creative industry and media and entertainment and making movies. Here it's all about just showing off your product in the best light in the most realistic way possible. So you only have 2 main controls, and that's lighting and material. Okay, there are 2 methods of rendering, local and cloud. Okay, obviously the definition of local is going to be using your own PC to render that. Cloud, it will use the powerful cloud computers or a network of cloud computers to render perhaps a large design, something that will take a long time to do on your PC, no matter how good of a PC you have. Sometimes a fairly complex design will take a lot of time to render. So using in the cloud can save you a lot of time, basically. Okay, some renders might take a day or 2 if you just leave it on to render to its ultimate rendering quality. And whereas if you do it on the cloud, it will do it in a few minutes or an hour. Okay, and like I said, you can create realistic visuals for a brochure or client presentations, and you can also insert a decal. So if you want to insert your company logo onto the model itself, you can see they have included the Autodesk logo, and it conforms to the shape of your model, and this gives you a better idea of what the final product will look like. Okay, and of course, sorry, this is the last toolpath. This is the last workspace. and it's basically the manufacturing workspace. So this regards, like I said at the beginning, CNC and getting G codes out. So you've modeled your part and you want to get it directly to your CNC factory. Okay. You can import or draw your model in design and then simply move to manufacturer and create a CNC program directly. Okay. The manufacturer workspace is separated into the different types of CNC operations. So you'll see at the top here, you have milling, turning, additive, inspection, etc. So it's designed to say, okay, you have this part, for example, on the right. I want to do a milling of this part. So basically, I want to mill out those pockets in there. I can set up my job just by working in the one workspace and not be bombarded with all the other tools for turning or fabrication or anything like that. So I've listed them down here: milling, turning, probing, additive, fabrication. Utilities is just a tool set, so it's not really included in here, right? The 3 basic steps to creating a CNC program. Well, that would be, you'll start by creating a setup. You'll create or pick the tools that you want. Then you'll be able to generate toolpaths, and you'll see on the top here, you have it divided into 2D and 3D toolpath strategies. So we know the difference between 2D and 3D strategies. Well, if you're into CNC, you'll be able to know that. But the gist of it is that 2D will create toolpaths for each step down. So it'll basically do everything on one level, step down in the Z direction, and do everything on the next level, and so on and so forth. Whereas 3D can go from one Z level to the next, to another Z level, to a next, and it doesn't necessarily rely on stepping down and then clearing everything at that level. So that's the difference between 2D and 3D. Okay. So with all that information, I'm sure I've bombarded you with a lot in a short amount of time. I think it's now time for a live demo of what all of that would look like. So I'm just going to switch over to Fusion 360. And here we have our Fusion 360 workspace. So you'll see that it was the same thing I was talking about, separated into workspaces, my design workspace in particular. And on the left here, I'm just going to click out. You'll see that I have a project panel. And this is what I was referring to when we spoke about Fusion 360 in the cloud. All of these are folders, and I say folders in inverted commas, they're called projects. So I can make a new project here called live demo. And that will fall under a new project. I'm going to pin it up so that it lives on top here. And I'm just going to filter it out and show only my pinned one. So this is my project. And when I double click into it, you'll see that I have the name live demo, and I can go back home and so forth. Now in this project, remember, I have data and people. So data is where all my files are going to live. So if I make a new design and I save it, it will live here. Right? People are all the people that you invited to collaborate on this particular project or folder. Right? So here's the people tab and here's the data tab. Okay. Notice also that in this project tab, you need to note that I will not be able to work with parts between projects. So if I have a part in one particular project here, I need to make sure that I only collaborating with stuff inside of this particular project, right? If I want to use a part somewhere else, one is that not the same people will be included, and two is that I might not be able to take that part into this project. So you just got to be aware of that. Keep a main project folder and have subfolders inside of that. Okay, I'm just going to start a new design with my design workspace, and we're going to go as quickly as possible just to show you a gist of its modeling capabilities. So I'm going to start by doing a simple sketch and a block. Now I'm going to just draw a simple square. And I'm going to make that 200 by 150. Now, like I said, I might be doing a speed run because, of course, this is not a training session, but more of a overview of capabilities. I've just finished my sketch. Notice that it's quite neat that sketch, the one I've just done, gets recorded on my timeline here on the bottom, as well as it gets its own folder with all these sketches that I've made in this design listed here. Okay, the moment I use the sketch, like so, you notice that the sketch, the visibility icon has been turned off. And now it says, well, you've used that sketch, so you probably don't want to use it anymore. And now that I have a third dimension, I have my first body. So this is basically a body in Fusion. Notice I'm still working with a part and I haven't done anything else yet. Now, parametric modeling, we said that parametric modeling means that everything's based on features and constraints. So I can do, for example, another sketch, right? But I can now reference another face. So in this case, this face, the top face, and I will just give myself some guidelines before I begin. And you'll see why I'm doing this just now. I just made a little light construction line there. And now what I want to do is just draw some shapes that I want to cut out. So parametric modeling, meaning that I can do this. I can simply draw my shape very freely, rough-handed, just eyeballing it. And let's say 50. And come in later and define my dimensions. So I'll say 100 by 50. Now, of course, because I've only defined those two things, those stay locked, they're constrained. It's parametric, remember? And I just need to make sure that it's in the center. How do I do that? I can make another constraint forcing that one and that one to be symmetrical about the center. And everything else stays locked. So now you'll see all these little icons, they're telling me what's constrained about what. For example, that's symmetrical about the center, that's horizontal, that's vertical, and that's at the midpoint. Right? Similarly, I'll do this on here. And I'll just say maybe 65 by... Okay. Again, I can do roughly the same thing. That one and that one should be symmetrical about that. And that's basically it. So you can see how parametric modeling helps constrain and define everything. Although that was basically with sketch constraints. Okay. Now that I have that, I can move on to features. Notice how everything I do is being recorded. I did the first sketch, I did the first body, and I did the second sketch. Remember, when I use a sketch, it's going to disappear, but not a problem. I can always turn it off when I need. So I've used that sketch, it's disappeared, but it is still here. It's just turned the visibility off. Right. I'm going to use that same sketch to cut out something else. Notice how each of these have been recorded. So this is now a feature, 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 feature. And parametric meaning that features can be referenced. So I can go back and edit this feature and it would change the way the model looks. So if I right click and say edit feature, I can say, actually, I don't want it 15, I want it negative 16. And we can see that it adjusts accordingly. Okay, I'm just going to draw one more little extrusion. Okay, and then we're going to take it onto the we're going to try and take it onto the manufacturing workspace. Of course, I'm just going to show you how to model using assembly mode. Okay, I'm just going to say 120 and maybe 25. I'm going to use the same symmetry constraint in there. Okay. So now I'm going to go, let's say 25 again. Now what I want to do is I just want to add some, you'll see that now that I have drawn my first body in here, I've been adding and deleting away spaces, and I've got a 3D model like so. The nice thing about parametric modeling is you can make changes to whatever edges and lines you have intrinsically from the model. So I can say, okay, I want to change that and that. Maybe let's give it a 10 mil radius, and I'm good with that. Perhaps the same thing here. Maybe just 15. Okay. Next thing I want to do is probably give this a chamfer. So I'll look at a chamfer and I'll say, I want to make that edge. Right. And I know that, I think it's, I can't remember what I made this, but I'll just measure it. I made that 25. Right. So I can create a chamfer. Right. And I'll say to distance of maybe 25, 25. 25. Okay, that's good. So now I have a little ramp in there. Right. I'll do the same here. Notice how everything again is being recorded. Where's my chamfer? There we go. I'll do that again. 25, tab 25. And we have a fairly complex shape. I can still go in and machine these, or sorry, not machine, make them machinable by saying, let's say, make that a 10. So I've given them a radius, and we are good to go. Okay, now, because it's parametric, I can always make a new place to draw and still cut out. So for example, if I wanted to do something like this, and I'm just going to say 12.5, and I'm going to now sketch onto that plane. And I'm simply going to give myself another guideline. Oops, let's just try and project, first of all. You can see that I'm snapping onto midpoints here. Those are the triangles. And I will give myself a nice slot in here. So I'll use a center to center slot. But I can just rotate it as I see fit. And if I'm not happy with it, I can sort of move it where I want to. So for example, if I wanted to move it here, I'll just say, all right, I'm going to move this a little inward, and let's say 10 mils. So it's going to stick out a bit, but the idea is we want to cut through this bit here. So I'm going to say, right, let's cut this out, and we'll say symmetric total length of, let's say, 10. Yeah. Right. Alternatively, I can just go in and say, right, I'll just go to one side and go all the way upwards. I think that would be simpler and more easier to understand. Instead of distance, I'll say through all. And now we've cut out a shape there. Okay, so that's all good. And notice how if I want to save, I haven't saved this yet. It's just called untitled. Nothing's been uploaded to cloud. It's just locally. It's saved somewhere in a temporary files folder. And if I lose this, it will still have that temporary file. So let's say the power goes off, load shedding happens. I'll still be able to recover it. The next time you open it, it'll ask me, I have a part file that was not saved. Would you like to recover it? So you aren't completely lost. However, it saves periodically, I think once every 5 minutes or something. So there might be the very last features missing. Anyway, I'm going to save this now into my live demo project. You'll see that it takes me to the application live demo, and I'll save it as my CNC part. Okay, I saved it as that name simply because I'm obviously going to take it for the purpose of this demo into my manufacturing workspace. Okay, you'll see it comes like so, and any change that I make here on will be updated into a different version. So you'll see it has a little bit of version control, and we can actually revert to previous versions. Okay, so for example, if I go in now and I make, let's say, let's just make some, I'm going to, I suppose I should make some holes. All right. I'm just going to make it as simply as possible. Okay. So I've made 2 holes there, and I save this. Right. It's going to ask me for a little description, and I'll say perhaps added holes. And you'll see it's doing its thing. It's got that little turning symbol there. It says, okay, now it's saved. Notice version 2. And if I drop down the box, it says, okay, first time it was created by me. Second version, version 2, it has a little note there, and what I did, added holes. Okay, so that's basically the workflow. Right, so I've just shown you part creation. As per our slides that we went through earlier, what happens if I want to create a or an assembly, right? Well, the simple thing is you can do one of 2 things. You can make an external component, and I'll show you that first, or you can make an internal component, and I'll show you that second. So how does an external component work? Well, it'll mean me creating a new design and simply going and saying, okay, well, I know that my part was, I think, 200, 150. What? I'm going to extrude this, let's say 10 thick, and I will save this somewhere here, right, as maybe lid. So let's just say I'm saving it in the same location, so you should see it pop up right here. Okay, just 1 second, guys. Okay, there we go. It's saved here. So that means I can go back to my CNC part and simply come in here and drag it into my part. And notice now that the icon here where my mouse is changed. It is now 3 small blocks indicating that it is, in fact, a or an assembly. Why? Because basically it now has an external part. So I can move this in place where I want to. I'm not going to for now. And I'm just going to say, okay, that is supposed to sit on top of there, or maybe on the bottom here. So maybe I'll just say I'll joint. And I'll say, okay. We won't focus too much on the options I chose there. Like I said, this isn't a training session. This is more an overview. Okay, so now you'll see that I have another component inside of my CNC part, which makes it an assembly. Okay, that was creating an external component. How would I go about creating an internal component? Well, an internal component would be working with multiple bodies. So if I go and do this, and you'll see it's much easier. And I say, okay, I'm going to perhaps project all of that, right? I'll say, okay, say finish sketch. And now what I'm going to do is I'm going to extrude. Oops, let me just select all of that. You'll see that I'm able to create quite easily just using the projected sketch. And I will use, let's say 10. And I will use the feature called new body. This will create another body on here that I can convert to a component. So I'll say, okay, you'll see that that becomes body 2, and it's this bit. And it's quite easily where I didn't have to go and remember that it was 200 by 150 and remember the size of the holes, because I just based it on the sketch that was here. Now, mind you, it's still not a component yet because it's just a separate body. What I've got to do is right click it and say create components from bodies. And now there it is on the bottom here. It looks just like the other one, minus the little chain link icon. Notice it won't appear here. So that's what I was talking about when I said internal and external components. And I highlighted the blue and the green. I said an external component would occupy a space here in your project, whereas an internal component we created from a body here may not. Right? You still have the option where you can create a new component and you'll be able to specify that it's internal or external. But I didn't do it that way. I used an existing body and I created a new component, and it doesn't have the little linked icon. Okay, so that means this is now free to move and free to constrain any way I want it. So in this case, I'm just going to constrain it the same way, fixed, rigid, can't move. Although I can do any motion that I want. For example, if I wanted to revolute, I can. Okay, I just want to show you what that looks like. That will revolute about a certain point. Right, I'm just going to keep it on rigid and say, okay. So that was basically part and assembly creation. Now let's take a look at if we were to take this to the render and drawing spaces. So I'm going to take it first to render, or rather, let me take it to drawing, since that's the next logical step. And I think I will show you render with a different design. Okay, I'm going to take it to drawing, and from here we can say I want to make a drawing out of this design, right? I can choose contents full assembly or maybe select. So for example, if I only want to select certain parts to my drawing, in this case, I just want to say, okay, choose my page size, my settings, etc. And it will take me to the drawing workspace. The drawing workspace will allow me to place a view and project views from there. Okay, so I'm going to make it 1:2, for example, and I'm going to place this on here and say, okay. You'll see that I'm able now to project views quite easily to get some engineering documentation for this, right? I can also go in here and say, actually, you know what? I want to view all the visible edges. So I'll say, okay. So view all the visible edges. Well, there's no invisible edges, so that's okay. Great. And maybe this particular view, I want to say, actually, I just want this to be a shaded view so that the person can see. Maybe I'll change the scale a little bit. I'll say 1:3. And that's how it will look, right? I can make some cutouts, sections, or breakouts. So for example, if I look at a sectional view, I can say, let's cut this in half, or maybe I'll do it cleverly. So you can actually see a section. So I'll cut out from here to here. And you'll see here exactly what the sectional view will look like. And you can choose to show. It will section it out for you and show you the cut lines. I can also do a detailed view. So I can look there and maybe do a little detailed view in there to show exactly that curve and maybe. And then of course, the most important thing we want to do is give center lines, bend lines, and annotations. So annotations are simply a matter of clicking point to point for linear dimensions, like so, or clicking on a line, clicking between, for example, two lines to give an angle, maybe that angle, clicking point to give certain areas. You click on a circle to give radius or diameters. So for example, that is a radius, and so on and so forth. I can click between two lines as well and give overall heights. Of course, you've got center line, center mark, patterns, and all of that, as you would in any other software. Lastly, I can also set out, so I'm just going to neaten this here. I can also set out some parts list and tables. So for example, if I want to look at labeling each of these parts, I'll say, okay, that's one part, and that's another part, and that is another part, right? I'll say, okay, cool. I've only made two in this particular design. You saw me make two. I'm just going to move this across, right? You'll see that my parts list table includes lid and component one, and it shows exactly which one is which. If you change these numbers, you can say renumber, they will swap around and it automatically lists it for you. You don't have to go and change it manually. Okay, and that was basically the drawing workspace. Of course, there's weld symbols and all sorts of other things. Again, that is for the training. This is a basic overview. Lastly, when you're ready with this, you want to send it out to PDF to send it to your manufacturing or your client. Okay, you go export to DWG, PDF, or DXF. Okay. Next workspace I want to talk about is, we've only got about 10 minutes more. I hope you're still interested, but we're going to wrap this up shortly. I'm going to use this design I made earlier. It's a little bit of a generic headphone type thing, and we're going to discuss the render workspace. So once I'm happy with my design, you can see I just made it use the same concept of bodies and multiple components. I'm going to go into the render workspace, and you'll see that the lighting and the environment changes, and now you're able to see the materials more clearly. And what you have is, like I said, lighting and material controls. So for materials, you can, for example, list here. You can go and look at each of these bodies, components, or faces, right? And you can apply a different set of materials to it, right? So for example, if I wanted this headband to be aluminum blue type of, I can go in here, I can adjust this, I can even edit and change the color exactly to my liking, right? And it's going to render using the same lighting that we set up here. So for example, this, I chose like a leather material, which is included in the library. You also have the option to go and apply your own texture. So if you have a photograph of a texture and you want to use that exact texture, you're more than welcome. Okay. Yeah, that's basically applying materials to your bodies and faces. Okay. Then we have lighting settings where we can adjust the brightness and position of where the light sits. So as it rotates around the part, just to give it that finish. Okay, we can insert or remove a ground plane. So if you're having something that needs to show a shadow, you can. And you can also place what type of camera view you want, whether it's perspective or in orthographic mode only. And then, of course, there's camera settings for exposure and focal length. Right. Also, you have the option to include a mapped environment. So a 3D projection map that's going to, I'm just going to try and double click it. Give it a second. You'll see here that I have the option to show the environment, for example. So if you have a 3D projection map, which you can download online from many sources, a lot of software uses 3D projection maps, or you can create your own, up to you. You can just have an image where you want to put it in an environment, you can, right? And then after that, it's a matter of simply creating an in-canvas render or a render using the cloud or your own local PC. Here, cloud or local, right? and you'll be able to click render. I'm not going to do it now, it will take a while, but the finished product, you can see I have some examples here. So for example, this, I've played around with the materials, I've changed a few things, and this was the finished product I got. It looks like so. You can see quite the finish on this. So this can go directly into a brochure or what have you. I have a couple of other examples here with different variations. I think, yeah, there we go. So that would be the render environment. Okay. Right. And of course, to finish off, we're going to discuss perhaps the most complex one, which is the machining environment. I don't know if I have any setups here. Okay, I don't. Okay, let me just use the one we were playing around with, which is the CNC. So once I go to the manufacturer environment, you'll see that it takes me to exactly exactly the CNC space where I can choose between milling, turning, additive. Sorry, I've clicked the wrong thing there. Additive, inspection, etc. Okay. Now you'll see here that I'm able now to go in and create a setup from this. So for example, I'm able to say, okay, I want to machine this, but perhaps not everything in here. So I'll just tell it my model is only that. Right? And then I'll go into my model and I will hide what I don't want to see. So for example, component 1, and maybe that's the one I want to see, component 2. So those I don't want to see, but in my setup, I want it to take into account everything here. So you'll see I'll be able to create a setup for this and basically tell what's my z-axis, what's my x-axis, and what my stock material is. So this yellow bit is basically my starting stock. And I can say that's going to be my 0, 0, positive x, maybe in another direction. I'll say let's select the z and y axes. I'll select z, and I'll select, sorry, x-axis. Right, and I'll flip the x-axis around. So I'll say that's my starting 0, 0, and I'm going to machine from there, etc. Okay, now that I have that, I can choose to clear or face or mill or do whatever. So for example, if in my setup I had, for example, maybe a couple of mills on the top. So if you look at the top, I'm adding a few mills to the top. I'm just going to change the display to like so. So if I look at the top, I've added 3 mills. If I want to do a simple facing operation, I'll say, all right, let me do a face. I'll choose a tool. Where can I find a tool? Right, and I'm going to say face off this within this bounding box. Again, this is not a training. This is just a very brief overview of what it can do. And you can say, all right, let's do this face. And it's going to face off this. In the same way, I'll use another tool, come in and machine, take out this pocket, etc., etc. I'm just going to show you what this looks like using a simulation. Okay, that was a bit fast. Maybe I'll just slow it down a bit. But you can see it shows you exactly what the tool is going to come in and do. Okay. In the same way, you'll be able to take off this bit of material, that pocket, ramp up there, and you'll be able to machine the full final part. And I think that brings us to the end of this demonstration. Hope you guys enjoyed that. That was, like I said, an incredibly sped up overview due to time limitations, and of course, this being not a training session. If there's any questions, you're welcome to post them now. And anything you want to know, or maybe you can just take down my details that you see up screen if you want to contact me regarding further information. I will leave my details on.
Hade, can you hear me?
Yes, I can.
Hi, my name is Hubert. Thank you very much for that presentation. It was really nice. I've
Good,
got
thank
a
you.
I've got a couple of questions. Uh, Quite a few, but I just want to start with maybe how big assemblies can Fusion 360 handle? Is there like a parts limitation?
Okay, so there isn't a hard set limitation, but we would generally advise uh, if you're looking at under 1,000 parts or under 500 parts, I would say, you can use Fusion effectively. The reason I say that is there is technically no limit, but the reason I say that is because management of that part data, you probably want to use Inventor, which has like a bill of materials and a structured way of organizing IPT and IAM files. Um,
Yeah.
yeah.
Can you bring in standard components, like say a motor that you've got from Beckhoff or something? Can you put that
Yes,
in the
so
Fusion
if
360?
you
Okay.
can. So like I
Okay.
said, with any CAD, you can bring in any type of data from any other software. If you're getting that motor, for example, from their website and their catalog, right, they'll probably give it to you in step file, which is a general CAD format.
Yeah. Yeah.
And yeah, you'll be able to import that step file directly in and build your design around that.
So is there like a folder, like a local folder that you would put that file into, or is it all on the
No,
cloud?
it's all in the cloud. What you're going to do, and I'll show you now. What you will do is you will say, well, actually, firstly, you would say whatever project you're working on. So let's say you would include your motor in here. You would simply go in and say open, and you'll say open from my computer.
Okay.
You'll find that local part. It will open another window. I don't know if I have any local parts that I can. I might. Okay, wait, let me just.
Because I know in Inventor, then you'd make like a project file,
Correct.
and then in there
Yeah.
you'd have all your folders with your standard parts and your manufactured parts and your assemblies.
Yes,
So
yes.
is there a similar way to keep everything together?
Well, only in the cloud. What you have locally won't really matter. You'll just import it and you'll see it here in your cloud. You'll make a copy onto the cloud. Okay.
Okay.
I just want to see if I have. Um,
So for the
uh,
specific design, you'll just make a folder on your computer, like for my CNC part, and then
correct.
you'll just have your standard components in them and just pull them from there onto the cloud.
That's it. Um, okay, I'm looking for some. I don't. Okay, not on this PC. I have on another PC, but you will be able to pull in if I can
No,
show
that's
you
fine.
stuff.
Can you pull in fasteners as well?
Okay, so you're looking at something similar to the Inventor Content Center.
Yeah, something
Okay,
like that.
yeah. Okay, so by default, let me show you here. There is an insert, and it has this McMaster car component. So Fusion has moved away from that content center, leaving it to third-party developers to develop stuff where you insert parts, right? So as an example, like I said, by default, they have a particular brand that comes in. So you do have this, but remember, these are going to be standard parts. So you can just use it and not obviously have your part numbers attached to them. So for example, they've got fastening and joining. They do have screws and bolts that you can place in here. It's a little, my opinion, slightly more cumbersome than
Hmm.
Content Center, but it is a little bit more flexible and more, I think, for new users, easier to see where and what things are. For example,
Do
it
you
tells
have
you the
to
unit.
do you have to pay for it?
This particular one you don't have to pay for, right?
Okay, so it
But there
isn't.
are others on the App Store. So there is a little Fusion 360 App Store where you can download add-ins. Okay, and
Okay.
there might be a better one that has standard components in there. I'm not sure. I haven't really
Yes. Yeah. Yeah. Yeah.
paid.
No, I understand.
Okay, but like I said, by default it comes with McMaster and it seems to have most of what we want. It's quite involved,
Yeah,
and
it seems like it's
they will
almost got
have
more than more than content center.
yeah, yeah, and it, like I said, because we're using standard metric or imperial, it won't really matter on the brand. I mean, they're all the same. So
Yeah. And can you do like inventors, which I think is quite often used as a frame design? well, not design, but like your
Frame
frames,
generator.
frame generator. Yeah.
Okay, so again, it doesn't have frame generator out of the box, but there are add-ins. There's one that's almost, I think, like 80% similar to frame generator, where you just draw a sketch, you pick your lines, and
Yes.
it'll give you a basic gym. But I believe that one that I saw was paid for. And
Okay.
it's like, yeah, I'm not going to lie to you, I think it was like about 40 US dollars. So just to give you an idea.
Okay. Do you know if that would be a once-off cost, or would you
Yeah,
have to renew
normally
your
they are a
license?
once-off cost. Yeah.
Okay. And
Okay.
when you were doing the parametric modeling earlier, or just showing the modeling, is there a way to define parameters? So ones that are linked, say you want to
Yes,
link your width to your height,
there is.
with, okay,
There's
there we go.
almost the
That's
same
fine. Yeah,
parameter
that's
window as
exactly the
Inventor.
same. Yeah, okay. And you can also just in the sketch environment, click on another dimension so that you link the two. Say you want your width and your length to be the same one. Can you just click
Yes.
on the, okay, so
Yeah,
you can quickly link it like that as well.
correct. Yeah. But mostly I just control it from here, and if you give it a name and you type in the same
Yes.
name, that usually
Yeah,
links it up.
no, definitely. So why would people use Inventor and not Fusion 360?
Good question. So they're trying to throw. Remember, Fusion 360 is the new kid on the block. It's basically, if they remember, Inventor started like I think in 1994 or 1997, so it's quite bloated now when it comes to after all these years. Fusion is like the rewrite. It's like saying if we had to write a 3D parametric modeling program in the 2010s, what would it look like? And that's what it
Yes.
came out with, right?
Okay.
Of course, trying to steer established companies who've been using Inventor since 1998 away from that, and we've got all their systems, all their bill of materials, all their IPTs and stuff. Trying to steer them away from that is going to be a big ask, right?
Yeah.
They obviously don't want to do that. So what they did instead was that they threw a lot of features into Fusion 360 in the hopes that the new guys, the new startups, and the hobbyists and students and stuff like that start using Fusion 360 because they're going to be the big companies of tomorrow. And
Okay.
if they start on Fusion 360, then slowly Inventor will die out. So
And
that's
is
why
that
you
so you think that's going to happen? Inventor is going to become a thing of the
probably
past because
it looks
everything's
like it
going cloud-based.
that that's one, but also remember, I mean, you're getting simulation, animation,
Yeah, yeah,
generative
yeah.
design, all of these things for like a third of the price
I
of
know.
Inventor.
Yeah.
So, of course, like I said, with things like Content Center and your design accelerators, iLogic, and all those fancy tools, you're not going to get it here. But it's a different target market altogether. They're not targeting those established big companies that have, built their entire lives
Yes.
around it. They're
Yeah.
targeting newer startups and hobbyists.
Yeah, almost smaller scale in a sense.
Correct. Yeah.
Yeah. Okay. Do you guys have a demo for your generative design and FEA, like a webinar for that?
Um, there might already be one. Can you just type in your email address into the chat box? I'll find it and I'll send it to you.
Yeah, sure.
One of my colleagues, I think it was Carl, who conducted that webinar, and I'll send you the link.
That would be awesome. Thank you.
Okay, cool.
Sorry, can I ask one more question?
Sure. No, go ahead.
What are the competitors of Fusion 360? I know SolidWorks, do they have like a 3D experience or something that they call it?
To be honest, I don't know. I wouldn't know at all. Every time we talk about Fusion 360, people are blown away because there's basically no competitor in this price space and in this
Yes.
offering space
Okay.
that can compete with Fusion 360.
Yeah. Do you have to buy out, like I know for generative design, I think you have to buy credits and things like that. Is that still like that?
Good question. It's a good question because they recently changed it.
Sorry, let me jump in there. Sorry, what was the question? This is already done.
So just with
Okay, wait, let me just
with using in generative design, do you have to buy credits and things externally, or is it a once-off cost for Fusion 360?
So I think they've changed the model to when you buy Fusion, you can actually buy Fusion with generative design. You get unlimited designs through that here.
Okay.
But just for clarification, just chat to the salespersons because they keep abreast with all the different pricing changes.
Okay. Cool.
Yes. Thanks, Eldred.
Cool.
All right.
And
Yeah.
then
So
the competitor for Fusion 360, I think probably the only real competitor with Fusion 360 is probably OnShape.
Yeah.
So
But
that,
they're
I mean,
different price bracket.
yeah.
that's why I said
You can't really compare it, and I mean a lot of the Fusion 360 is a lot of guys are taking it for just the CAM capabilities. So you'd see people using a CAD package, 3D CAD package, and for their CAM they'd be using Edge CAM or Master CAM or something like that.
Yeah.
And they're now starting to look at Fusion 360 for their CAM capabilities.
Yeah. Do you think would it move over to like tablet-based modeling? Like I know Sharper 3D is a big thing at the moment for the iPads. And OnShape you can also model on an iPad.
Yeah, from what I've seen, no, I don't think they'll do that.
Okay.
Not in the near foreseeable future. I know that there is an online, like you can go into the internet browser, and use it on there, but it still doesn't have the full functionality as the full-blown install on your computer.
Yeah.
Cool.
okay.
Any other questions?
Not from me, thank you. That's my list.
Okay.
Thank you very much. That was great.
Okay. Right, thanks very much, guys.
All right.
Risha,
Thank you
very much.
Right.
Thank you. Cheers.
Cool. Cheers. Bye.
Cheers.